Bom dia, good morning. I'm very happy to be here today because I'm really confident that the Brazilian community of physicists could contribute a lot for the national development, working together with other professionals in Brazil. So I'm glad to be here, and I would like to thank the organization of this meeting, Philip, Jessica, and Joe, that we had a lot of contact to be here. Also, Joania Mello from ICTP, Newton Frateschi, thank you for the nice introduction. And I would like to say that I enjoy a lot being here in Campinas, very close to the Gleb Vartag Physics Institute, very important institute in Brazil. And also I would like to thank my partners in the oil field NMR area, Vinicius Machado and William Trevisan from Petrobras, and our colleagues from Schlumberger, Martin Hurliman, André Souza, Austin Boyd, and Ichao Song. Really nice to have this environment in Brazil. And also the sponsors of this meeting. The outline of my talk, I'm going to talk with the perspective of introducing the ideas we have about industrial physics. For that, I'm going to say a few words about the University of São Paulo that is celebrating this anniversary, 8 years. Later on, I'm going to talk a little bit about the Institute of Physics in São Carlos, 20 years. And after that, I'm going to talk a little bit about what we are doing in the oil field research area. University of São Paulo is reaching this age, reaching good positions in international rankings, and it's nice to show this one, at least, this very nice position among the BRICS and emerging economies. And also, University of São Paulo has huge numbers. We have about 10 campuses in 7 cities along São Paulo state. We have about 60,000 undergraduate students and about 30,000 students for the post-graduation system. For that, we have 66,000 professors and about 17,000 technicians and administratives. For that, we are taking care of one population of above 120,000 persons working, studying, and collaborating with University of São Paulo. And we reached this big number, more than 100,000 masters and PhD students that concluded their dissertations in physics in the University of São Paulo since 1969. It's really a big number. And also we take care of several museums, 2 good reference hospitals, a lot of science centers, and other facilities. The São Carlos Institute of Physics, despite celebrating 20 years, we started our activities in the physics department inside the São Carlos School of Engineering, and we stayed working with the engineers during 18 years. After that, in 1971, we constituted one Institute of Physics and Chemistry, and we worked together with the chemists during 23 years. This was very useful for us, and since 1994, we are working alone with our independent institute only for physics. But we are very happy to have 61 years, and we have a good line age because we have worked a lot, and we understood how good is working with engineers and the chemists to get good results for science and the technology. Our researchers from the Institute have been working intensively on aspects of pure theoretical and experimental research, and also research, development, and innovation over the last decades. Also, our R&D activities are not limited to pure physics, but extended to areas such as material science, structural biology, medicine, dentistry, and computer science. In order to cover this wide range of research activities, our institute counts on academic staff members and specialists from many different fields of interest, including engineers, computer scientists, biochemists, biologists, chemists, pharmacists, and dentists. Due to these reasons, our institute has several collaborations with companies and a considerable list of patents and spin-outs. And we have a lot of important contributions for the industry in Brazil, because some of our professors were contributing for the creation of the Brazilian Agricultural Research Corporation in São Carlos. This is a very special unit that was presented yesterday for you by Dr. Silvio Crestano, a speaker yesterday. We were also collaborating for the creation of the pioneer incubator that emerged from the first public policy in Brazil to stimulate the transfer of technology from academia for the productive sector, led by Professor Silvio Goulart Rosa, also professor of our institute. And also we are really proud to be able to have professors providing ideas for creating many companies in São Carlos. And I would like to highlight optoelectronics that was also presented yesterday by Professor Jarbas Caiado de Castro. And nowadays, due to all these contributions for the industry and innovation, Professor Vanderlei Banhato, that was the first speaker in this meeting, is leading the USP Agency for Innovation. So our institute is always trying to be very close to the innovation in Brazil. This is a good example of the contributions we have in our institute. We have constructed one magnetic resonance imaging system that was installed in a hospital in São Carlos and operated during several years in the last decade. And due to this reason, this professor, Professor Horácio Panepucci, gives the name to one hospital in São Carlos. So, I mean, a physicist giving the name of a hospital in São Carlos. This is really indicates that the contribution is very exclusive for the scientists contributing for the society in our city. And we have a lot of initiatives. We created the Science, Technology and Innovation Committee in São Carlos Institute of Physics, which is responsible for providing institutional guidelines in order to stimulate activities that may result in research, technological development and innovation, establishment of collaborations with industries, inviting and visiting companies in order to identify research topics and present our skills for the companies, trying to find research funding outside the traditional system, and very important, creating perspectives of employment to our graduates in industries. And finally, consolidation of physics as a fundamental knowledge area for the required Brazilian technological development. Our institute is a little bit small. We have about 8 faculty, 20 of them non-physicists. We have about 200 non-faculty and over than 700 students, undergrad and grad students that can follow 4 options of education: traditional physics, computational physics, biomolecular physics, and physics teaching. And we have a population of about 100 persons. And we have a lot of good facilities, a very good mechanical workshop, electronics workshop, optical workshop, glassware. We have a very good helium and nitrogen facility and a very good support for computers and softwares. Also, São Carlos Institute of Physics is traditional host for national or state research centers, including the well-known INCT, the Brazilian National Institutes for Science and Technology, supported by the Brazilian and the state science foundations, mostly in organic electronics and polymers, optics and photonics, and structural biology. And we take part of another national Institute for Science and Technology, led by colleagues from the Gleb Institute. And also we have several research, innovation, and dissemination centers founded by FAPESP, the famous CPD system in optics and photonics, and biodiversity and drug discovery, and other important centers. We have several reference labs, and we have highly inter and multidisciplinary activities in our institute. And for that, we can also be invited for organizing several meetings, and I would like to highlight this one. Last year, we were invited by the Brazilian Physical Society to organize the first industrial physics Brazilian meeting in Brazil. It was really successful, and we were expecting to have the second one next year, depending on the decision of the Brazilian Physical Society. And we also took part of this report for mapping the Brazilian physics community working in R&D inside and outside the university, together with the Brazilian Physical Society, the Center for Strategic Studies and Management for Science, Technology and Innovation, and the Brazilian Innovation Agency. I have this book in my backpack if you want to take a look. And finally, I'm going to start talking about the activities we have in our lab, Nuclear Magnetic Resonance Lab in São Carlos. Well, we are very happy because with the discovery of the Brazilian pre-salt reserves, we started having new money for research. And I'm happy because I took my luggage, I went to Petrobras, and I found a lot of interesting research to do with NMR. And I was accepted by them. For the reservoir characterization, we know that we need a lot of different physical techniques, and all these physical techniques can be used by the labs in the São Carlos Physics Institute. And we could offer several contributions, but in particular, in the area of nuclear magnetic resonance, we are doing a lot of contributions. We know that for the logging tool, normally you can use also nuclear magnetic resonance downhole, and this is nice because you can get very important information from relaxation times, translational diffusion, which are correlated with the morphological and the physical-chemical properties of the rock cores. And NMR is really very sensitive for measuring these parameters, something like being able to observe producible or not producible fluids inside the rocks. And also, we are at this moment trying to introduce some new techniques that could give you some idea about the permeability, indicating that we have mobility between different sites inside the rocks, or the flow between different pores, indicating that that fluid would be removed from the rock core. For that, we are implementing several methods associated with the measurement of relaxation times, diffusion coefficients, applying special magnetic resonance imaging techniques, and also applying spectroscopy. This means that we are using all the potential techniques we have from the NMR point of view to understand porous media or the fluid inside the porous media. This is one example of technique. I'm going to talk a little bit about it later on. And also, this is an image obtained from a rock core where people from Schlumberger they were able to open these wormholes along the rock core, and we were able to see perfectly this information from imaging. So we are improving a lot of methodologies, including faster NMR methods, and this is very good because in collaboration with Petrobras and Schlumberger, we are being able to give good steps for understanding rock cores. And of course, we need the collaboration of people from geophysics, geosciences, and mechanical engineering to give much more information about this technique and these materials. Quickly, when we do NMR in porous media, we could have this ideal porous media where we have two pores with different sizes. In a very simple way, we could associate the relaxation time T2, it is proportional to the pore size. If the T2 is proportional to the pore size, I could have for this sample, ideal sample, two T2 values, one for pore A and the other one for the pore B. And if I have motion between the molecules can move from pore A to pore B or vice versa, I can get very good information about fluid molecules migration, translational diffusion, and I can correlate this exchange process with the permeability. And this is really good for understanding rock core reservoirs. And this is interesting. I'm not going to explain everything about NMR. This is a very complex close sequence, but normally I have techniques to measure T2, and I can measure T2 in two different instants of time, separated by this storage time where there is no relaxation. So if I measure this relaxation time before and after this storage time, I can construct 2D maps as a function of this storage time that could give me important information about the migration of molecules from pore A to B that is contained in this off-diagonal peak. I can get all the information about these peaks from pore A, pore B, the migration of molecules from A to B or from B to A, I can construct several build-up curves that are associated with three processes: T1 relaxation, T2 relaxation, and the exchange process. So from these curves, and knowing the T1 and the T2 values for both pores, I can get very nice exchange build-up curves. From that, I can get good information about the typical exchange time, and if I know the diffusion coefficients that I can measure by NMR techniques, I can have good ideas about the pathways and the distances that molecules can migrate along the porous medium. Oh, so this is really nice, and we are really, in fact, in this moment, proposing new NMR techniques that could give the same idea, but 10 times faster than the two-dimensional techniques. This is really a good contribution. And for understanding or simulating these curves, I need models. And the models we are using are called the two-site exchange models. I'm not going to go through the equations, but they are really important for us to be able to get the information about the exchange constant times. And if you have diffusion coefficients, you could estimate the diffusion pathways along the sample. And for testing the new techniques, it's really hard to work with real rock cores. For this reason, we are constructing, in collaboration with engineers, some artificial porous media composed by alumina mixed with sucrose crystals. We mix these two powders, and after the sintering process, the sucrose is burnt. It goes away from the sample, and we can get very nice artificial porous media composed by sucrose-induced pores that have sizes about 100 micrometers, and also we have the intrinsic porosity of the sample. So we have two-site sample artificial porous media, and we can control the intrinsic porosity, the induced pore sizes, and also the porosity. And for these samples, we can also add some paramagnetic impurities to be closer to the real rocks. So this kind of sample is really very good for us to understand the techniques and the computational simulation methods we are proposing. And also, using the 3D X-ray microtomography, we are being able to get the morphological information about the samples, and getting very special regions of the rock core. We can use computational and statistical physics methods to understand the migration of the molecules, water molecules, for example, along the porous medium. And this is very nice because we can estimate the distances, and using diffusion coefficients, restricted diffusion pathways, collision rates, and we can calculate the relaxation times and correlate this with the porous media morphology and the physical chemical properties. And this is really good because we can understand the intrinsic migration of molecules, or also we can put pressure on the rock core and try to use NMR techniques to understand also the flow through the pores. And using that simulation, we can get good correlation between the simulated NMR experiments and the real experiments using the artificial rock cores. Of course, we are not using only artificial porous media. We are studying a lot of several rock core families, including collaboration with Petrobras, Schlumberger, Geophysics Institute in University of São Paulo, and the Institute of Geosciences, also in the University of São Paulo. And last week, I was visiting the Center for Information Technology here in Campinas, and we started the collaboration to try to make artificial porous media prepared with the 3D printers. So we are really excited to have all discovered about techniques to understand porous media in collaboration with some companies. And finally, we are doing a lot of efforts also to construct one NMR spectrometer for applications in oil science. This project is in partnership with TechMag, an American company, and this is applied for studying porous media in general. And for that, we are developing our own software for example, obtaining the T2 values. We need inverse Laplace transform, the numeric simulations, and also we have to have some software to control the spectrometers. And also, we are constructing a lot of accessories, including probes, with radio frequency and magnetic field gradients to operate under reservoir conditions, 2000 psi and 150 degrees C. And this is being done also with SAMPs, our colleagues are around here. For that, these are examples of the self-shielded and radio frequency coils and the high pressure cells that we have a much more modern configuration at this moment. And with this project, with Petrobras, we are improving the spectrometer, and now we have a spectrometer that operates from 0.1 to 500 megahertz. And with this spectrometer, we could do a lot of new experiments, including spectroscopy in very high field, get images from around 85 megahertz, and do relaxometry as a function of the magnetic field, remembering that in the rocky cores we have magnetic susceptibility. In order to understand the effects of magnetic susceptibility, it's important to change the magnetic field. And we are not working only with NMR or oil science. We have some companies collaborating with our group. I would include over here. This company is located in São Carlos. This company is responsible for constructing the petrochemical pyrolysis pipes. They are using petrochemicals. And we are studying the steel carbonization process that occurs due to the diffusion of carbon along the steel alloys. And this is very interesting. And we have one student from the company for getting his PhD in our group in the physics metallurgy. And we have one of our students also working this project to construct some carbonization or magnetic sensors. This is not including NMR. We have also collaboration with Faber-Castell. We are analyzing the industrial heat treatment for improving wood and pencil properties. And we have 2 students of our group and 1 postdoc from the company also working in our lab. And also Schlumberger and Petrobras, I have already explained or showed you what we are doing in São Carlos. And we are doing a lot of efforts. And fortunately, we have a former PhD student now working in Schlumberger and in our group too as a collaborator, and we hope that we are going to improve this collaboration with this nice company. And in Petrobras, we have also one PhD student already hired by Petrobras too, and finishing his PhD working with petrophysics, NMR, and live oil research, using the spectrometer we are constructing at this moment. And in our lab, we have also, besides these guys, we have 1 postdoc, 7 PhD students, and 1 master student working in all these techniques in order to get good information about rock cores and other experiments I'm going to tell you soon. And soon we are going to have additionally 3 postdocs to help us to understand rock cores and other experiments. So in our laboratory, using NMR or techniques very close to NMR, we are being able to put our students finding employments for them in the universities, but we are using this model of collaborating with companies and putting the students for master or PhD. They are being able to find very good jobs in several companies, international or Brazilian companies: Schlumberger, Bruker, Philips, GE, TechMag, Samsung, Toshiba, Faber-Castell, Engemas, and the Petrobras. We are very happy because we are providing our effective contributions to put the physicists to collaborate or start working in the companies installed in Brazil or abroad. This is our team in São Carlos. We have about 20 persons. It's a really very young team. And we have here the students, very good, and the collaborators from Petrobras is sitting over here. And we have also this collaborator from Schlumberger also sitting here. And this one is also sitting here. He's going to be the next postdoc in our group. And we have 1 technician, very good for mechanics and electronics, and this engineer that is really good for radio frequency, for constructing coils and instrumentation for NMR. And we have 2 good collaborations, Professor Ricardo from Geophysics Institute in São Paulo, and also Professor Fortulan helping us construct the artificial rock porous media. And we are not working only with porous media instrumentation. Our group has also very good research for quantum information using NMR and NQR. We are doing a lot of zero-field NMR for understanding magnetic materials and studying polymers and derivatives using very advanced solid-state high-resolution NMR techniques. So I'd like to thank University of São Paulo, FAPESP, CNPq, and CAPES, our very good agencies, and Petrobras, Schlumberger, Engemasa, TecMag, and Faber-Castell for offering this additional perspective of collaboration with companies in Brazil. And thank you for your attention, and meeting organizers for the invitation and support to be here. Thank you very much.